this optimization problem is about the maximum product of three numbers, x, y, and z. So the problem says the sum of three positive integers is 72. So we have x plus y plus z equals to 72. One of the integer is twice the value of another integer. The sum is equals to 72. I want you to find the maximum product. So x, y, and z. Tell me what these three numbers are so that the sum is equals to 72. The product is maximized. All right. So for optimization problem, we have three functions: primary and secondary. Primary is based on the problem. The problem says find the maximum product, right? So I am going to call that the primary function. The product is equals to x times y times z. But this function has three variables. We can only deal with one function with one independent variable. So we will have to find a way to rewrite y and z in terms of x. That means we will have to move on to the secondary equation. So for secondary equation, that is about what is given. They gave me that the sum is equals to 72. So I am going to say that x plus y plus z is equals to 72. But that is not enough to get rid of one of the variable. So we will have to get another given. The other given is one of the integer is twice of the other integer. So I'm going to say that y is equals to 2 times x. So take the x, multiply by 2, that is equals to y. And then we will update the secondary function to here, to x plus 2x plus z equals to 72. All right, we just plug this in to here. And then we have 3x plus z equals to 72. And then let's rewrite the z. The z is equals to 72 minus 3x. All right. And then we will plug this z to the primary. And then what about the y? Y is equals to 2x. And then y equals to 2x. We also plug that in to the primary. And then we rewrite the primary as, so now is p equals to x times y is equals to 2x, and then z is equals to 72 minus 3x. So this is in one independent variable, and then let's call that p of x. All right, clean that up. So you have p of x equals to 2x squared, right? So you have 2x squared times 72 minus 3x, and then let's go one more step. So we distribute. So p of x is equals to 2 times 72, that is 144, x squared, and then minus 6x to the third power. So now we are ready to take the derivative. So we have p prime of x equals to, bring the power down, we have 288x, and then minus 18x squared. We set that equals to 0. Why do we need to take the derivative and set that equals to 0? We are applying the concept of local or relative minimum and maximum. So imagine you have a curve going up and down. So for the maximum, we are looking for the maximum product, right? So that's why we will have to take the derivative and then set that equals to 0, because we would like to find the maximum. Because in order to find the maximum, we will need the slope. The slope must be going up and then horizontal and then going down. And then at the point where the slope is horizontal, we have a horizontal tangent line and the slope is equals to 0. And then that's why we set the first derivative equals to 0. And then you have to find the critical numbers. So you have to, I will just factor out a 18x. So this becomes a 16, no x, 16 minus x, and then we have that equals to 0. So this one we have x equals to 0, and then we have x equals to 16, and they are critical numbers. And then what about what is the highest x? What is the highest x when we test the critical number? So here is how you find the highest x, because you don't want x going to be infinite, to be super big, like x equals to like 1,000. That doesn't make any sense, right? 1,000 plus 2 other integers, how can that be as equals to 72? So to find the maximum, you have to do a little trick right over here. Is I don't want to have a z to be negative, so I'm going to use a different color. So what if z equals to 0. So when z is equals to 0, we have 0 equals to 72 minus 3x, and then we have 3x equals to 72, and then what is x equals to? So x is equals to 24. So that is the maximum x value. X value to avoid negative z. Right? Because when x is too big, we will have to use negative z in order to get some equals to 72. So when you do the testing, the highest x you can go is 24. Okay. Okay. Now let's do the let's find the maximum. Okay, so let's find the maximum. So for the maximum, we will have to go this way. I'm going to draw a number line. I am going to do a 0. We have to block this off because we do not consider negative. And then we have a 16, and then the highest we can go is a 24, and then we block the rest off. And then this is about x. So we have to test 0 to 16, and then test 16 to 24. And then test something easy. So how about x equals to 1, x equals to 17? These are called test values. And then the intervals are called test intervals. And then p prime of 1. So you plug it into the first derivative. Where is the first derivative? The first derivative is right over here. This line, 288x minus 18x squared. So plug it in. So you have 288 times 1 minus 18 times 1 square. That is definitely positive, right? And then when you try the 17, this one I did the math already, that is negative. So this one for the slope, we have an increasing and then a decreasing. What do we get? Increasing, 0, and then decreasing. So we just get that x equals to 16 is a maximum. So when you select values, you have to select x equals to 16. That will give you the maximum product. And then I ask for x, y, and z. You only have x, so you have to find me the rest of them. But before we get into that, let's show that when x equals to 16, we have a maximum product. So at this point, we have x equals to 16. We also have x equals to 0 and x equals to 24. We need to make sure at x equals to 16, we have a maximum product. How do we know? All you have to do is you plug that into the primary function. Where is the primary function? Can you tell me that? So the primary function is right over here. Right over here. We need to plug it into the p of x equals to 144x squared and blah, blah, blah. All right, so that is the primary. So let's do the work. So we have a p of 0. So we are trying to find, I'm trying to use a different color to do this. So we are looking for, let's use orange. So we are looking for find the max, absolute max product, absolute max product. So we call that p of x is equals to 144x squared minus 6x to the third. That is our primary. So we have p of 0. We have 144. This is just a 0. Minus 60 to the third. So this is just a 0. That is definitely not the maximum product, right? And then 16. You have 144 times 16 squared minus 6 times 16 to the third power. So this one is equals to 12288. And then when x equals to 24, unfortunately, this one after the plug-in, the product is equals to 0. So that tells me the 12288 is the max product. Maximum product. And then can you tell me the x, y, and the z? Sure. So x equals to 16. Y is twice, right? So y is 2 times 16 equals to 32. And then for the z, you will be using they said the sum is 72, right? So I will be using the 72 minus the x and then minus the y. So z is equals to 24. So here is your x, here is your y, and then here is your z. And that is the end of this problem. So it's a little bit more challenging comparing to two variables, but that is still doable. And this is a pretty good exam problem. Alright, so that is the end of this video. If you like the way I explain problems, give me a like, share the video for me, click the subscribe button if you are new to the channel. I have many more optimization problem explained on my channel. So I will see you all in those videos. Signing out.